Hi everyone, today we're going to talk about the greenhouse effect, which contributes to global warming. This effect primarily occurs in the troposphere, which I want to remind you is the layer of the atmosphere that is closest to Earth's surface. Before we jump into the greenhouse effect, I want to define global change. Global change is an umbrella term or an overarching concept that includes changes that occur in the chemical, biological, and physical properties of the planet. So this overarching concept of global change includes global climate change and global warming. When we talk about global climate change, I just want to remind you that that means a change in the average weather patterns that we see on Earth's surface. In the most basic sense, the greenhouse effect begins when the sun emits solar radiation that strikes Earth's surface. As our planet warms, it emits radiation back towards the atmosphere, and these two forms of radiation are not the same. So the sun emits high energy radiation. These are visible radiation and ultraviolet radiation. Once these two types of radiation strike Earth's surface, the planet warms and radiates energy back out into the atmosphere in the form of infrared radiation. Infrared radiation is lower energy radiation and it can be felt as heat. So you have definitely felt infrared radiation before. For example, when it's really hot out, if you walk over an asphalt road or a dark surface and you feel heat kind of radiating off that, that's because the heat that you're feeling is infrared radiation that is being released from that surface. Unlike UV radiation, infrared radiation doesn't pass through the atmosphere easily. It actually gets absorbed by gases that are called greenhouse gases. So when these gases absorb IR, it causes them to warm up. The warmed gases emit infrared radiation back out into space and back towards Earth's surface. So it's emitted out in all directions. So some of that goes out into the atmosphere up to higher levels of the atmosphere, and some infrared radiation gets emitted back towards Earth's surface. This effect is really important because if we didn't have these greenhouse gases that basically trap in this heat, the Earth's surface would be far too cold to support life. So Earth would be inhospitable if we did not have the greenhouse effect. The greenhouse effect, just to kind of define it, is the absorption of infrared radiation by atmospheric gases in the troposphere and the re-radiation of this energy back towards Earth. Under normal conditions, the energy input into Earth is equal to the energy output from Earth, meaning that our system is usually in steady state. However, in recent years, the Earth has been accumulating more and more greenhouse gases, so we are trapping a lot more energy than is actually being dispersed out into the atmosphere. So our atmosphere is primarily made up of nitrogen gas and oxygen gas, which makes up 99% of it. These two gases are not considered greenhouse gases because they don't absorb infrared radiation. So what this means is greenhouse gases make up a very small fraction of the atmosphere, less than 1%, and they still have a really big impact. So when we look through this list, I'm going to walk you through a few different greenhouse gases. The green words are natural processes that release these greenhouse gases. The words that are in red have anthropogenic input. So that means humans are contributing to the release of these gases into the atmosphere. Our first greenhouse gas is water vapor. Water vapor is a greenhouse gas. It does absorb infrared radiation. However, it does not persist in the atmosphere for very long, so it really is not a significant contributor to global climate change. Water vapor is released into the atmosphere through evapotranspiration. Our next greenhouse gas is carbon dioxide, which is released by volcanic eruptions, by decomposition, and also by humans performing combustion to receive energy from fossil fuels, and also when we perform deforestation in order to harvest lumber for whatever we need it for. Methane is another greenhouse gas that's released by agricultural practices and released from the materials that are kind of clustered together in landfills. Nitrous oxide is released naturally through denitrification. This is a step in the nitrogen cycle. Its concentration is increased as we begin to use more fertilizers. And then one that I really want to highlight is ozone. So I know we just talked about ozone. It's really important in the stratosphere because it's part of our ozone layer that filters out UV radiation, keeps us from getting more skin cancer and from getting cataracts and things like that. However, ozone can also be created in the troposphere. So in this troposphere, it's created through reactions between chemicals and sunlight. It is harmful because in the troposphere, it's a greenhouse gas. It also can damage plants and it can damage human respiratory systems. So ozone in the troposphere is considered quote unquote bad ozone. Ozone in the stratosphere is considered good beneficial ozone. Then the last greenhouse gas that you need to know is CFCs. These are released because they're used in refrigerants and aerosol sprays. The last concept you need to know is global warming potential. So global warming potential, or GWP, is an estimate of the impact of different greenhouse gases. So it's an estimate of how much a given molecule of gas can contribute to the warming of the atmosphere over a 100-year period. We use carbon dioxide as our comparison molecule, so it's given a GWP of 1. Although it has a low GWP compared to other molecules, it's very abundant in the atmosphere compared to other greenhouse gases, so it still has a very large impact, and that's why we're still worried about carbon dioxide. Carbon dioxide has a GWP of 1, methane has a GWP of 25, nitrous oxide has a GWP of 300, and our CFCs are molecules with the highest GWP. So we can see that these molecules all have a really big impact on the warming of our atmosphere. For your practice FRQ for 9.3, I would like you to explain how greenhouse gases in the atmosphere contribute to the heating of Earth's climate.